Hello all, welcome to the another LeetCode problem. So today we are going to solve the problem number 2415 where basically we have to reverse the odd level of binary. So what does it mean is, so every odd level you have to reverse the node values. So in order to start with this, so let's say, so what is the odd level here? So when you start a binary tree traversal, so root node is considered to be a 0th level. So depth is 0, and then if once you go further down, then followed by 1 and then followed by 2. So the 1 is odd level and then 3 will become odd level, but you have to remember that odd level start from the traversal start from 0. So next level is 1, so L1 will be odd. You don't start from 1 so that you do the reversal the wrong. Now, so it's for this for example, in this example is given as the odd level is 1, so you have to switch the node value between this level. Make sure you don't switch the entire tree, you just switch the values here. So 3 will become 5 and 5 will become 3, and the rest of the values remain as it is. If you switch the node, then it will entire tree will be switched. So that's one catch here. Another catch is when you have bigger tree. So in this example we just have 1 0 1 2 level, right? Let's say you have 3 level, then you'll have total 8 nodes because it's a perfect binary tree, right? So every node will have 2 children. So in that case, so this is example they have given. Let's say if you have 3 levels, then how the reversal will be. So let's say 2 1 3 4, this is the order at the bottom, then it should become as 18 19 18 29 11 7 4. Just to understand this one, right? So I don't have example of the level 3 tree, but for example, let's say this is a node we want to reverse, right? So you have 8 here, 13 21 and 34. Now when you want to switching a values, so it will become, so this won't be there, so it will become 34 21 13 and 8. So one thing to notice here is when the switching is happening, right? So left node of this particular tree is being switched with the right node of this particular tree, and the same way the right node of this particular tree is being switched with the left node of basically 21, so left node of the parent tree, right? So that's the key here. So when you're switching, you have to remember you're switching the opposite node of the particular node, a particular parent. So this is a, this will switch with this and this will switch with this, right? You don't switch 8 and 21. No switching from left to left, switching from left to right and right to left, like in that, right? So that same applies to here. So you have to switch from left to right, right? That's a thing, logic here. I mean, that's a overall problem statement here. So when you're traversing a tree, right, what you're going to do is you just traverse the tree separately, because we know that at the root node we are not going to do any switching. So root node is always be 0, so that is going to be always even node. So there's nothing is required. So I'll traverse each tree, left tree and right tree separately. So this is my left tree and this is my right tree, right? So when I'm traversing left and right, but the traversal will be such that in the left tree I'll traverse the left node first, but in the right tree I'll traverse the right node first, and then I'll swap the values as soon as I reach the odd level node. So let's say I'm traversing this tree first, left tree, and then traversing right tree first. Let's say this is an even node, considering this is not there. This is the even node, so I don't switch it. As soon as I reach odd node, whatever value I assign here, because since I'm traversing right tree first, I mean in the right tree I'll visit the right node first, and then in the left tree I'll visit left node first. So when I'm traversing here, so I'll reach here first, and then in the right tree I'll reach here, and then I'll swap the values here, and then I'll do after that I'll traverse this particular node, and then I'll traverse this particular node. Basically, so just to give another, let's say this is root, this is left, this is right, right? This is my tree 1, and in the tree 2, this is root again, this is left, this is right. So when I start traversing from here, so I'll go to the left node first in the tree 1, but in the tree 2 I'll go to the right node first, and then I'll swap, and then once the left node is visited, I'll go to the right node, and then in this case I'll go to the left node, which is here, right? And then I'll do swapping. So let's look at the code here. So as I explained, I'll split the tree into left and right first. So since I'm doing left and right, so see, I'm already starting from left and right, so depth is already 1 because I'm not starting from the root node, right? So depth is already 1, so that's why I have given 1 here. Now I'll see whether the depth is basically odd node, which is here, then I'll swap the values. Now the important logic comes here when I'm traversing the first tree, that is tree 1, that is root 1, and the root 2 is another tree. I'm traversing on the left side first, and then in the root case of tree 2, I'm traversing on the right side first. So same thing that I explained here. When it comes to tree 1, which is basically root 1, I'll traverse the left side first, but in tree 2, I'll traverse the right side first. And then again, I'll compare again. And likewise, it will keep going. Then I'll switch the traversal, root 1 dot right and root 1 dot left. And then recursion will take care. And then finally, the resultant root will be returned. That's the overall logic here. So if you test this, yeah, it works fine. And then you can just go ahead and submit it. Alright, 96%. Thank you. Thanks for watching.